This video is on balancing word equations. It will look very similar to the last video in terms of just balancing. That has not changed. Now we're just going to take into account the fact that you might not always be given the formulas, so you might be given the words. So you're going to have to use what I call the 3F's to deal with these equations. So first you're going to have to get the facts. This means like you're going to have to determine the ions from names of ionic compounds. So this is all from last chapter. So for instance, if you're told the name is potassium bromide, let's say, the facts would be writing the ion. So you've got K plus 1 and you've got Br minus 1. So those are your facts. Next, you're going to need to write any and all formulas. If it's ionic, now you're going to put the ions together. If it's molecular, you're going to look at the prefixes. So here's where you would write K, Br, because you've got plus 1 and minus 1. So crisscrossing would just be one of each. Once you get all the formulas, then you do what we did in the previous video, which would be to balance. So I call this fulcrumizing. If you remember, back in 9th grade science, we talked about levers, and the fulcrum is this right here where the lever kind of balances on. Okay, like a teeter-totter balances on that middle piece. It's called the fulcrum. So you got to get the facts, so that'd be writing the ions, determine their formulas, and then balance it, so fulcrumize it. Couple things before we do a couple practice is you need to know some elements are what we call diatomic. If you remember from before, the prefix di means two. So diatomic, so we've got two atoms. So some elements will always be in groups of two if they're in their pure state. So in their pure state, they exist in groups of two, let's say. In groups of two. So there are 7 of these, and you will have to know what they are. This is, remember, like I said, the pure state, so not when they're with anything. So these 7 are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And you could just write their symbols if you want. So what that means is whenever you see these elements by themselves, like just oxygen, or just bromine, it's going to be written as 2. So you're going to have H2. Okay, if it's just hydrogen. If it's just nitrogen, it's going to be N2, and so on. Okay, notice up here, right, this bromine, there are 2. The number of bromines here comes from the formula, right? There was -1, +1, so there's only 1 of each of these. Okay, when it's just bromine by itself, not in the compound, then it's Br2. So these you're going to need to know. A way to remember them, if you look them up on the periodic table, so look them up on the periodic table, you'll see, start with nitrogen, and then going to the right, you've got oxygen and fluorine, so those 3, and then you go down, chlorine, bromine, iodine. If you look at the shape those 6 of them make, they make a 7, because there are 7 total. And they point at the 7th one, which is way over to the left, hydrogen. So that's how, one way, a little trick you can remember by looking at your periodic table. 2 other things, these names are things that you will have to know. CH4 you're going to see from time to time, and you're going to see the name. So you need to know CH4 is called methane. Okay? And another one you'll see is NH3, which is ammonia. Scroll down. Okay. NH3 ammonia, it's very similar to our polyatomic ion, NH4 plus 1. That's called ammonium. So the way I remember the difference is ammonia is a smaller name, and NH3, it only has 3 hydrogens, so that's less, smaller, less. Ammonium is a longer name, and you've got more hydrogen, so it's a bigger molecule. So longer name goes with the bigger molecule, or ion, I should say in this case. Another one you'll see is H2O. I think you all know what this is. Hope you all know what this is. Water. Okay. All right, so let's do a few practice. All right, so number 1, Helps to read the whole sentence first. So sodium metal and chlorine react to make sodium chloride. So you kind of have to decode, as in where's the plus sign, where's the yield, the arrow sign. Okay, so we've got sodium metal. So my facts are going to be sodium metal. That's just sodium. Don't let the fact that it says metal throw you off. That just means it's a solid. So if we wanted, we could say it's a solid, but we don't need to do that quite yet. So we've got sodium metal, okay, and chlorine. And is going to be our plus sign. Okay, now we're going on to something different. Chlorine, that is one of these 7 diatomics right here. Just chlorine. So that would be Cl2. And sodium is not one of those 7, so it's just Na. These two things react to make. If you're making something, it's a product. So after our arrow is going to be where we list our products. So we've got sodium chloride. So our facts would be sodium is Na plus 1, chloride, so it's just the element chlorine minus 1. Not diatomic when it's in a compound, you use the charges. So plus 1 minus 1, so it'd be NaCl. Okay, so we've gotten our facts, and then we took our facts and wrote our formulas. Now we need to fulcrumize. So I'm going to go through sodium. I have 1 over here and 1 over here, so those are balanced. I'm underlining just to show you which ones I'm talking about. You do not have to in your work. Chlorine, I've got 2 here, and I've got 1 over here. So on the product side, I need to get 2, so I'm going to put a coefficient of 2 here. Now my chlorines work out. Sodium, I have 2 over here, so I'm going to have to go back to the reactant side and put a 2 there. So there's my balanced equation. Let's do another one. Barium hydroxide. All right, so my facts are I have barium, so Ba plus 2. Hydroxide is OH minus 1. Okay, so I'm going to put them together, so I get Ba, and then I need 2 hydroxides, so OH, and you got a parentheses here, take it twice. Okay, moving on, and, so plus. Sulfuric acid, so if it's an acid, it has hydrogen. Sulfuric, so it doesn't start with hydro, so I have a polyatomic ion, it goes to 8. So it's SO4, sulfate, minus 2. So it would be H2SO4. And those two things make water and barium sulfate. So make, so there's my yield sign. Water we know as H2O. And barium sulfate, so plus, I could rewrite my facts, but they're actually already over here. Notice I have barium right here and sulfate right here. So you can rewrite them if you want, or you could look back. So plus 2 and minus 2, so my formula would be VaSO4. So I've got my facts and I've got my formulas. It's really important that you get the formulas and the facts correct, because if you don't, the third step will not work out. You can't fulcrumize. So for fulcrumizing, what's going to be helpful is writing water a different way. This was said in the earlier video, video 1. It helps to write water like this in this case. Not every time, but this time it is. And here's how you know. When you have on the other side of your water, if you have OH as one thing and H, it helps to write water as H and OH and think of it as H and OH. So now you're looking at polyatomic ion hydroxide and the element hydrogen. It actually makes it easier to balance. So if I go through my barium, I've got 1 on the reactant side and 1 on the product side. Perfect. Hydroxide, I have 2 on the reactant side and I only have 1 on the product side. So I need to put a 2 in front. So then I've got 2 hydrogens on my reactant side, 2 now on my product side. And sulfate, I've got 1 here and 1 here, so there's our balanced reaction. Let's do one more. So aluminum sulfate. So I've got Al, and that's plus 3. Sulfate, SO4 minus 2. So putting them together, I'm going to get Al2, parentheses, SO4, parentheses 3. And, so there's my plus. Calcium, Ca, plus 2. Hydroxide is OH, minus 1. So I've got CaOH taken twice. Become, so there's my arrow, aluminum hydroxide. So I've already got my facts written. Here's aluminum. We're going to put it with OH minus 1. So I'm going to get Al, OH taken 3 times. And so plus calcium sulfate. So here's my calcium. Here's my sulfate. So plus 2 and minus 2. So it'd just be CaSO4. Okay, now to balance this, all right, 2 aluminums here, so I need a 2 here in front of this for this one. Sulfates, I've got 3 on my reactant side, so I'm going to put a 3 here for my product side. Calcium, okay, I've got 1 here and I've got 3 over here, so I'm going to have to put a 3 in front of my Ca on the reactant side. And this gives me 6 OHs, so I have 6 hydroxides over on the product side. I also have 6 hydroxides. So there is my balanced equation. Try the next 2 on your own to be prepared for class tomorrow.